Hey everyone, happy to be here. Let me click this. Okay, that works. So we're going to talk about benchmarking Noir. First of all, I'm very sad that I'm not wearing one of the lab coats from the Noir guys, but I'm wearing one of the Hyli t-shirts that says zero knowledge proof in French. So I just really want to make sure that this was captured on camera. So there we go. So at Hyli, we have done a bunch of work. So I'm Sylve, blah, 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 co-founder of Hyli. We've done a bunch of work benchmarking different options for client-side proving. And so we've done some work, like very concrete work about benchmarking different options, and especially Noir. So I'll give you a bit of context of what we do at Hyli, go into more of the benchmarks, the results, the future, blah, blah, blah. So we're now one. Everything on Hyli is a proof. We're hacking proofs into the blockchain most of the time, and what we've done at Hyli is that we have designed an entire blockchain network to fit proofs. So we support major proving systems, Noir, obviously, otherwise I wouldn't be here. We're Zero and SP1, and we aim at just supporting all of them. So very simple. This is Steve Ballmer, proofs, 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 proofs. That's what we do. We've made some very concrete design choices. There is no execution environment. So you don't run code on Hyli. You just send a new state, send a proof, and you're off to the races. We have very fast DA, and some of the stuff that we have done with Noir, for example, is that we don't even have a concept of an identity. You just send a proof of who you are, and you're good to go. So I'll let you look at more of this. We're not here to talk about Hyli. We're here to talk about Noir. Small plug, we just have released the testnet, so you can scan the QR code and use the Noir good code, do it really fast before the dev team kills me, because I'm not supposed to do this. And you can see that the wallet that we have built on Hyli uses Noir. So it generates a zero-knowledge proof that you know your password and provisions the session key. So we're really happy about this one. It means that you can use the same wallet on your phone and directly on your computer. Seamless, great experience, Noir good. Thank you, Aztec, for building this. So, benchmarking Noir. Why did we do this? The reason is, if you want to prove something, there's always a bit of an overhead, obviously. So most of the time and most of the research has been spent to make sure that it's very easy to prove and it's getting faster to prove on a server. Main use case being Ethereum blocks, rollups, etc., etc. But there are some use cases where you cannot prove on a server, especially when it's privacy sensitive. So there's a great project called ZK Passport that allows you to generate a zero-knowledge proof of a particular statement of a piece of signed data on your passport. I want to prove to you that I'm over 18. I want to prove to you that I'm French. I want to prove to you that my first name starts with an S. But in order to generate a proof of this statement, I am not going to send my passport to the succinct proven network or to the boundless proven network. So I need to have a privacy-preserving option to generate such a proof without leaking everything. So that's where client-side proving comes in. The proof is generated on the end-user device directly. There are some other options there. The TateCO team is leading the march for co-snarks. So it means you compute the proof of multiple nodes on an MPC network. And I'm personally quite excited about TEE proving. I think it's fine if we just put a ZK VM inside a TEE and just call it a day. But we really get to see more of these things happening. In the meantime, really bullish about client-side proving. This was a slide from Nicolas Monblatt, aka the GOAT, about the trade-offs that you get between fast proving and fully private. So it was a really good talk that he gave at Zuberlin a couple days ago. So I stole his slide shamelessly. And you have some options. You see prove on the client device, fully private, but it tends to be quite slow because you don't have access to massive servers. And so there's a whole range of options that you can use in order to compute a little bit faster while knowing of some of the privacy aspects. So the question is, you want to benchmark, great. What are you going to benchmark on? The question that we're asking ourselves, so if you take, for example, ZK VMs, they tend to use these benchmarks, Fibonacci or EVM blocks. And it's pretty cool because it's a very, very practical example. For client-side proving, it's not necessarily very applicable. So what we thought about doing is proving of, what the hell? ECDSA signatures, specifically on the SECP 256R1 curve. So the mission, what is the best proof system for proving ECDSA signature verification on the SECP 256R1 curve in a browser? This is very specific, but it's an actual problem that we want to solve. So this is what we run the benchmarks on. Why specifically this curve? Because it's used mostly for all ID documents. So if you've been following, there's ZK Passport. These guys have a mobile app, for example. This is great. But what we're trying to do here is on a browser. And the reason we want to do it on a browser is because a browser is very, very limited in terms of the resources that it has. So we want to see what's the best option that you can have so that you don't even need to download an app. You can just use it everywhere. So the three criteria that we benchmarked against are proving speed, how fast does it take to generate the proof, memory requirements. To give you an idea, WASM in a browser on Chrome uses up to 4 gigabytes of RAM. On Safari, it's 1 gigabyte, for example. So it's very, very limited. And ease of use. So we wanted a tool that was easy to use. Lucky for us, we have a good friend called Vlad. This is him, as he said, the only broke dude in crypto that helped us build this benchmark. So give him a follow, check out his GitHub. And so the benchmarks that we run, we did it with SP1, RE0, Noir with the 2 different backends, Halo 2, and Cairo with Stu. I actually typed Halo 2 logo, and I was surprised to find the Halo 2 logo. Because there's none of there on Google. We thought this was going to be easy, in and out, 20-minute adventure. This took way longer than expected because some of these things is just not documented or it's just overall very, very difficult to use. So disclaimers on the results. First of all, we've done this work 5 months ago and we have not updated them. So please take this with a grain of salt. Second, it's a single data point that was done by a single team. Please don't get mad. It's a single data point that was done by a single team. Please do not get mad again. If you do not see the shiny double baby bear job curve on plum arm icicle with GPU acceleration, we're sorry, but we did not find it. And we should have included Ligero, but when we did the benchmark 5 months ago, it just wasn't there. So you're just going to see the benchmark done on all of this. So that's it, all the disclaimers done. What's the result? The result is, as you should expect, Noir good. And Noir came out on top by a very, very, very large margin. So if we go from bottom to top, Cairo, we didn't manage to make it work concretely. Halo 2 didn't work either. We didn't manage to make it work. RE0 and SP1, great options for ZK VMs, but it was just too heavy to run in a browser, so it didn't work. Circom, the proving key was too heavy, so it didn't work for what we tried to do. So we didn't use this. And then we ended up with Noir. So it was really pretty fast. We got it to 2 seconds on an M1 MacBook and about 6 seconds on an Android. And this is, like, bear in mind, we are not running any type of optimization here. This was run-of-the-mill type of, Vlad is a cryptographer, but like, he doesn't have all the context for all these things. So this was, if you wanted to use this right now, what's the best option that we would recommend? And we just recommend Noir. And this is the version for Noir and Beretenberg at the top. So Noir is good, but honestly, it could be faster. So please, Aztec team, just make it faster. But yes, Noir is good, and that will be the conclusion. Thank you. Any questions?
Thank you for the talk. Curious, what motivated the benchmark to begin with at the first place? Was it for prioritizing, for example, like which tech stack to support, Was it from user demand? Yeah, we'd love to hear more.
It really was to prioritize which one to work with. We currently support ReZero, SP1, and Noir, and we support both ZK VMs because they're great and they work quite well, but we really wanted to have a good option for client-side proving, because in terms of the applications that we want to build on Hyli, we want to have both applications that can be offloaded to proven networks and benefit from great stuff with GPU acceleration, et cetera, but maybe like 5% of the app must be completely private, and so we need to have a great option for this. So this is why we've supported Noir, and we wanted to be able to make recommendations to builder as to concretely what should I use, because we could support absolutely everything, but we'd rather support what works. So that's how we ended up doing the benchmark, and that's how we chose Noir.
Yeah, I wanted to ask about, I mean, there's a distinction between Noir and Aztec Noir, right? I mean, Aztec is a roll-up. Are you considering verifying the roll-up circuits in Hyli, and have you thought about, because you have all these extra kernel circuits and...
Sorry. Yeah, so verifying the Aztec circuit, and you were saying? Okay, that's the question. Yeah, we can verify that. We haven't prioritized it, but it's something that we can do. We support Noir overall. So this would mean that we just include another contract with the, yeah, just verifying Aztec. Yeah, doable. Cool. Thank you very much, folks.